So in this video, I'm going to go over sort of what's going to be on the exam, about how many points, probably tell you about 75 to 80% of the exam material so that you can go ahead and practice those things. So the biggest topic on the exam is going to be worth the most points is hypothesis testing. For hypothesis testing, you know there's going to be 15 to 16 points for your response. And then you're going to have at least 3, maybe 4 questions about the individual steps of a hypothesis test in the multiple choice framework. So that's about another, 16 points, maybe 12 points. Let's just say 12 points at least of multiple choice. And so for these, the multiple choice, as I've talked about before, for your free response or multiple choice, the first thing you need to decide is, are we talking about a mean or an average, right? Is the underlying variable that we collected quantitative? Or are we talking about a proportion or a percent, in which case the underlying variable is categorical, right? It's a binary yes-no variable. So once you make that distinction, that pretty much indicates everything that's going to happen after. For step 1, for means, we're talking about mu equaling something. I did notice as I was walking around in class yesterday that some people are still using like M for mean. You can look at mu and call it M, that's fine, but you do need to make sure that on the test you're using that Greek letter mu and that it looks like a mu. Otherwise, that doesn't mean anything statistically, that M, so you're not going to get a point for the right parameter. For proportions, I did not want to change my color. Maybe I'll do everything in blue. That'd be fun. Now we're looking at P equaling something. So being sure that you're in the right parameter land is super important. Step 2 is when we're going to go to our formula sheets. For our means, we're going to end up with a T. If you have the calculator, you're making sure you put t-test down on your formula, on your note card or somewhere that you can keep track of what the heck you're doing. For proportions, we're going to get out a z. These are both from the formula sheet, and the calculator people, you got one prop z test. So this step 2, is all formula sheet based. And just sort of a reminder that we're going into 2 different distributions depending on whether we're talking about means or proportions. Step 3 is when we go get our p-value, right? And here we're either going to, if you have the calculator, it's already done. Otherwise, we're going to the table. So for the t-table, just remember your degree of freedom is equal to n minus 1. And then you're going to be looking along that n minus 1 row, trying to find where the thing is, which is going to be between 2 values, and then going up and giving me a range of values. For the P, we're going to go to the Z table for the proportions. And remember, you do want to either think about your drawing, if we're doing like a right-tailed test, and you have a positive Z-score to look up, and then subtract from 1, or do my little trick of always looking up a negative. Ooh, we're not writing. All right, so that's our p-value. And then just a little note maybe on your note card of like, if we're dealing with a 2-tailed test, right, if our alternative is not equal to, make sure we multiply our p-value by 2. And we did have some people asking questions, am I supposed to multiply the p-value or the actual test statistic? Definitely the p-value, right? Because a 2-tailed test, we find the area of that tail and then we multiply the area by 2. We don't want to take that test statistic and multiply by 2 and move it over. That doesn't have any meaning and in fact would give us a smaller p-value. Also for hypothesis testing, step 4 and 5 are the same regardless of which parameter we're in or what type of variable we're dealing with. If our p-value is low, we're going to reject the HO. And if our p-value is large, we don't have enough data, we're going to fail to reject the null. All right, one of those has equal to. It is never going to happen that you get a p-value out of exactly 0.05, so don't worry about that. The 5th step is where we're going to make our conclusion. This conclusion should not say anything about rejecting the null or anything about the hypotheses. This is a conclusion that you could say to your parent, to your friend, to your younger sibling, and that they would understand what you were saying. So remember, we want to start with telling people how much evidence we use. So at a, we'll call it alpha % significance level. And then this changes depending on what we did. So if we rejected the null, we're going to say there is enough evidence. I meant to just tell you about points, and here I am doing the whole note card for you too, but oh well. Not enough evidence, blah, blah, blah. And always our alternative in words, which is what we're trying to do with our hypothesis test to prove that. So again, we saw this in class. You've seen it on the knowledge checks and in the practice quizzes, but especially when we're talking about these points in multiple choice, the things I usually like to have those questions on is like one more about hypotheses, right? Some of the wrong answers here are not paying close attention in your hypotheses to which values, right? If I give you a sentence where I say we have a mean of 50, and then later on I also say mean of 46, now you're sitting there going, well, which of those two means is going to go into my null hypothesis, right? Is it the 50 or the 46? And just a note to yourself, right, whichever of these is in the word from a sample, right, that's going to be our X bar. That's going to be our evidence that we would use in the second step. It doesn't go into our hypotheses. So usually this question here about the actual setting up hypotheses is more of a reading carefully for which of those two is the claimed value. I almost always have both the sample and the claimed value running around, and also reading carefully for direction on all that alternative. The other question I always put for multiple choice is a p-value one, especially because those students who have the calculator are just getting the p-value out from the calculator. This is my way to make sure everybody knows how to use the tables. So those of you with a little calculator, this is your moment that you're going to feel like a badass, where those people with the big calculator are going to have a little more work ahead of them. And then the last one, I love to have a conclusion question, just like that last question we saw in the Kahoot in class, where it's sort of like, well, where did the claim fall? Was it the null hypothesis, the alternative hypothesis? So those are the three that you're guaranteed to see as multiple choice as well. So we've already got 28 points of the exam down, right? Go away. Let's move on to our next, let's actually add one more piece of points. There's going to be a 4 or 5 point, I can't remember how much multiple choice is, probably 4 point error in context. So which of the following is a type 1 error? Which again, we saw so many times. You saw on the worksheet in class. So now we're at 33 points, or 32 points is what we'll call this. I'm keeping track so I can tell you how many points of the test you've already seen. We move on to the next biggest thing. So if you were studying, I would say focus on your hypothesis test, and then move on to confidence intervals. So the difference between a confidence interval and hypothesis test is in a hypothesis test we have some claimed value or claimed thing that we're trying to test. In a confidence interval we want to estimate the true value. All right, so that's the whole goal. And again, we need to pay close attention to whether we're in mean or proportion land. And there's two things I'm going to ask you to do. I'm going to ask you to calculate one, and I'm going to ask you to interpret one. These are guaranteed as a free response. So this here is 9 points worth of free response. The calculate is on the formula sheet, or if you have a calculator, you're either doing t interval or 1 prop z interval, or the formulas, and then interpreting, we are 90% confident. One thing I want to add about number 5, you do want to make sure, if you're not using the words of like somebody's claim, that you have the word mean or proportion or average or percent in your conclusion. Same thing when you interpret. your confidence interval. You definitely want to talk about the parameter of interest. That was a common mistake I saw with the worksheet in last class, with people just talking about the amount of time people are going to keep their car instead of the average amount of time people are going to keep their car. So those are the two. That's 9 more points. So now we're up to 41 points. Other things I like to ask, there's usually going to be some sort of multiple choice, usually 1 or 2 multiple choice. So let's say 8 points of multiple choice, usually about how to make our interval narrower, maybe even calculating another one, what that confidence level means. There was a lot of theory behind our confidence intervals. So you can expect to see some more questions. And as you look through the old test, you'll see this as well. So now we're up to 49 points of the exam. Within confidence intervals, we also talked about sample size. All right, so sample size, I'm going to ask you to calculate a necessary sample size. You know it's not going to be from means because that stuff is bananas, so it's probably going to be this lovely formula. Z star squared, P hat, Q hat, all over our margin of error squared, right? And likely it is going to be one where if we don't have P hat, use 0.5. And then don't forget we need to round up. So that's another 5 point for your response. So now we're up to 54 points of the exam. The last of the free response questions that is always going to be on there is a sampling distribution question. This is where we have our part A of describe the distribution, and we have our 3 different options. If we're talking about sample means, it could be normally distributed if we started with something normal, approximately normal if we started with something that wasn't normal, but we have a large enough sample to get normality, something greater than or equal to 30, and then our P hat, which follows an approximate normal. And then our part B is to use those normal distributions to find a probability. So again, this is at least a 9-point question, usually 4 for part A, 4 for part B, and now we're up to 63 points already guaranteed. The only thing that you're going to have to do is decide which one we're using for each of those. So what else is there going to be on the test? I always have some question about conditions or assumptions. Since I don't make you check them within each question, I definitely put a question about that. So you've got another 4 or 5 points there. I always have a question about either something theoretical in terms of the stuff that like let us do all of this. So either a question about the t-distribution or a question about the central limit theorem, right? So something there, just like what do we know about the t-distribution? Did we learn anything there? Or what is the central limit theorem? When does it apply? That sort of question. What else was I going to say about central limit theorem? Oh, I was also going to say about those sampling distributions. I do like questions that ask you sort of how they're going to change. As you saw in the knowledge checks and the practice quizzes, this idea that as we increase our sample size, our sampling distribution, right, if we're talking about it for X bar or for P hat, is going to be centered at the exact same place, right? So let's say we're flipping coins. We still expect to be centered at 50%, but the more coins we flip, the narrower this is going to become, right? Our standard deviation will decrease, and we'll get, if we didn't have normality, we'll start to move towards normality with that particular thing. So those are all fair game as well. Got errors. Oh, we haven't talked about duality. So the idea that a confidence interval can lead us to a conclusion by just looking at where the null value falls. To me, most of these are common sense. There's also that added piece of our confidence level is the complement to our significance level for a two-tailed test only, because, right, our confidence level is that middle percent. And when we're talking about a two-tailed test, we're looking at area to either side. So these two things are complements of each other, and definitely something I put on the test as well. So that's most of the big stuff. I'm trying to think if there's anything else that we talked about that I didn't get in here. But no, it's just basically the big four hypothesis test. Make sure you can do that warm and fuzzy practice. If you go to the back of your lecture notes, there's a ton of practice problems to try. If you go through the old exams, you're going to see a ton of different problems to try. You know it's either going to be means or proportions, and then whichever one it wasn't, you're going to see some questions for the other type of test as your multiple choice to make sure you could do both. And then confidence intervals are next biggest thing. Sampling distributions are actually the next, because there's going to be at least the A and B 9 points worth, and then probably one more. And then sample size is sort of the last little, like, oh, here's a 5-point throw on as well. So I'm going to post up a ton of practice exams as always. As you go through them, my suggestion is to sort of note on your formula sheet, like put a check mark next to every formula you use, and you'll see that again and again, I bring us back to the same formulas and we're doing all of them. So just know it's going to be just as fair as the old tests. If you use them as a study guide, you're going to be in really good shape. I also have a playlist of old review videos where I think I work through some actual problems. That's going to be linked right after this. So you should have no problem in terms of finding material to practice with. If you want anything else, email me, message me. I'll make it happen.